Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 7 of our main LeetCode challenge, and the problem that I'm given to us today is cousins in the binary tree problem. If you want to go through a problem description or you want to try solving this problem on your own, you can pause this video and check out the LeetCode link given in the description below. So the problem is pretty straightforward, and all we need to sort of worry about is just understand what the definition of a cousin is. So two nodes of a binary tree are cousins if they have the same depth but have different parents. So depth is basically identified like which level does a particular node really reside under inside a binary tree. So if you look at this particular example where you have this binary tree, if you're trying to compare 2 and 3, so to identify whether they have the same depth, it's pretty straightforward. You can already see they're at the same level, so that's the same depth. Or if it's really difficult for you to understand what that is, just pass in a horizontal line and see whether they're passing through. So when that happens, you can see that they are 2 and 3 are at the same depth, but they have different parents. So unfortunately, in that case, they would not be cousins. They would be siblings. So they've given us another example over here where you have a binary tree, suggested like this, and they're comparing values 4 and 5. So do note over here that 4 and 5 are at the same level, but they have different parents. Therefore, they are construed as cousins. So therefore, the output is true. So keeping that into mind, this problem becomes a lot more easier for us if we just, take a step back and just try to evaluate what all tools we already have. So you could do a simple in-order traversal to fetch out the value and just return the parent as well, and you're done. But all in all, you would also have to worry about which level you're presently at and maintain that as well. And if the interviewer sort of gives you an update on the problem, you'll have difficulties over there. So the problem is not really that, it's going to be difficult for you to scale it up. A better alternative to that would be to use BFS. So we have already established that we need level order traversal over here. And in my previous videos, I've already explained how you can do level order traversal using BFS. And if you're not aware of that, I would suggest that you look at that video, and you can find the link for that in the description as well. So all in all, what we want to do is we want to do level order traversal. So we are traversing at each level. And the other thing that we want to make sure is that if we find elements, if we find both the elements, we want to make sure that the parents are not the same. That's it. And then we're done. So let's quickly start with a base condition. And the base condition is just going to be if nothing's been given to us, then we return a false. All right, cool. And obviously inside a base condition, the way it sort of, sorry, inside a BFS solution, the way it sort of works is you maintain a queue. So let's just maintain a quick queue. And do note over here inside a queue, each element is not just going to be a simple root. It's going to be a tuple which is going to consist of the parent as well as of the root of the node. So let's say that the first element inside our tuple is going to be the parent, and the second element is going to be the node. So in essence, you can say node's parent and the node. So this is how the tuple is going to be represented. So this way we have control over what the parent really is and also which root we are presently at. So keeping that in mind, we'll start with our root, and root does not really have a parent. So we'll just say, hey, pass in none as the parent because it doesn't have any parent, and root as your value. So now that we've established our queue, let's just do a quick BFS. And BFS is pretty straightforward. Again, if you pause this video and check out the link, you'll see a lot of code is the same over there as well. And what we're going to do is we're just going to maintain another list so that we're not iterating, as you're sort of iterating on the queue, we're not updating the queue. It's generally not a good practice when you do that. So we're going to keep that in mind. And we're going to iterate for each value inside a queue. And if node exists, then we're going to append the values of node as the parent and node left, which would be its first child. And similarly for the right as well. Now what's going to happen is eventually we're just going to update our queue, and this iteration will keep on moving forward till we've iterated through all the values. Now we sort of already established we're going to do a level order traversal, and what I'm going to do is eventually if this thing pops out, we're going to return a false, which means that we didn't find anything. And what I'm going to do is I'm going to make a quick function, and in general interviews, it's a good option to just make functions if you're thinking of copying code. And the function is just going to do it's just going to try to find whether we can find a parent at a particular node. pretty straightforward. So what we're going to do is we're going to make this function. This is an inner function, so it doesn't really matter. But this function eventually, has a queue which is being passed to it. So this particular guy, and also it passes in a value that we want to like check. So let's call it x. Let's call it val because we already have an x. So what this thing does is it passes in the x and the y values one by one. This is going to be two calls to this particular thing, and it's going to iterate through each of these values. And while it's doing the iteration, it's just going to find whether it can find the node or not. So it's pretty straightforward. So we do a quick iteration like we did before, and we're going to do for parent and node because that's how our queue is constructed, doing a quick tuple unpack. And what's going to happen is we're just going to say, hey, if a node exists and a node val is equal to the val which has been given as a parameter, well, in that case, you need to return the parent. And you only return the parent val if the parent exists, because you might just get the root. Otherwise, you return a none. This is just for safety. You can just do parent val. And if this thing does not work, if the iteration does not really work, you can return a none. Sorry, so you return a none otherwise. So we're just going to use this function, and we're going to say parent x is going to be this of x, as well as parent y is just going to be us passing in the other value. So in essence, what's going to happen is that this find element parent is just going to iterate through our queue, and it's just going to find whether the node value is present inside this guy. If it does, it just returns it back, and it's just finding out whether x and y exist. You could also just set flags, and even that works, but I don't really like that idea because then you have to like maintain all your flags and all that stuff. So this way you have parent x and parent y. So there are certain conditions which might happen. So parent x and parent y might be returned as a none, which means that you do not find any elements inside your present level. Well, that sort of makes sense. So if that happens, we can still move forward. So let's just add that. We can say, hey, if our parent x is none, yeah, and parent y is also a none, well, in that case, we've not found any elements inside our present level. So in that case, we just say q equal to t. I'm just going to remove this. Otherwise, we have an else condition over here, and the else condition will be, well, if parent x is not un, and parent y is not none either, and what's going to happen if both of them are also not none? So we have three conditions where we have to take care of. Either this is none, or this is none, or both of them have some values, right? So that's this else condition block. And what we want to do is we just want to make sure that we return the correct value. So we just say, hey, we return parent x, and which is not equal to parent y. So what this thing does for us is it basically checks whether one of the values is basically if one of the values is none, and eventually, like, let's do a quick explanation of this. So parent x and parent y, let's say parent x and parent y returned values which were not none. So in that case, you already know you're at the same level, and all you want to make sure is that the parents are different. So this is a quick check on that. If they are, then you return true or false based on this thing. But you might also have a none over here because parent x is none and parent y is not none would still come into this block. And in that case, we want to return a false. So a quick one more condition over here would sort of help us out over here. So let's just do that. So we put an AND condition over here, and the AND condition is if parent x is not none and parent y is not none as well. So basically what you've said is, hey, both of these values that we're checking over here, parent x and parent y, they should have some value inside of it. We don't want to be checking on nones, and that's being controlled over here. If either one of them is a none, you return a false by this condition. And that's basically it. So let's go ahead and run this code, and hopefully this should run fine. And you can see it's running fine for now. Let's just go ahead and submit this, and hopefully this should get submitted as well. And awesome, you can see that's been accepted. Now, all in all that we've done over here, we've just used the same approach that we already had of level order traversal, where we use BFS. We use that already existing logic to iterate and set values inside our queue, And what we've done is we made a simple function which can just, iterate through all the values to identify whether there is a parent or not. And if there is, it just, updates the values. Now, there's multiple ways of solving this using BFS. I usually prefer this approach, but you might have different approaches and they might be more optimal than this. But I feel this is a lot more scalable as well because you bifurcated your logic and modularized your code as well. So awesome. If you have any comments or if you have any suggestions, do leave a comment in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here and we would love to have you on board with us. And if you've already subscribed to our channel, you're awesome. We all know it, and have an awesome day. Thank you.